Hello. In this video, I'd like to continue discussing the domains of functions algebraically. So in the last video, we looked at these graphs that were in the Module 1 lessons, and we talked about how linear and polynomial functions have domains that are all real numbers because I'm not violating any of the rules of real numbers when I plug any value x in their symbolic form, these equations. So one thing that I wanted to mention, this quadratic is a polynomial of order 2. Its highest exponent is a 2, and it's not written here, but there's actually a coefficient of x squared here that's a 1. If you look at this polynomial, it's a cubic. It's of order 3 because that's the highest exponent on any value of x. The exponents are only integer values, so this has an exponent of 2, this has an exponent of 1, and this minus 0.25 is the coefficient of x cubed, that's called the leading coefficient, and this is minus 0.75, the coefficient of x squared. The coefficient of x is 1. So we're going to see how to write a polynomial in general form with symbols in a minute. Now let's look at these other two functions. Here's a graph of the exponential function, and here is its formula or symbolic form. I can raise 3 to any power. The input to this function is an exponent of 3. I can raise 3 to 0, 10, pi, minus 52, 1/3. I can raise 3 to any power. That's why the domain of this function is minus infinity to infinity. There are no restrictions on what I can do in this formula. Note also that there are no discontinuities in the graph. Now let's look at the rational function. Here is the equation of this rational function. Notice that if I put 1 in this rational function, I'd have 0 in the denominator, and we can't divide by 0 in the real numbers. That's why this vertical asymptote appears at x equals 1 in the graph. 1 is not in the domain of this rational function. So we write the domain in interval notation as we've looked at before, but this is the algebraic reason. So if I want to determine where a rational function does not have x values that I can put in it, I need to look at its denominator, and I need to find what values of x cause the denominator to be 0. So remember that linear functions and polynomial functions have no limitations on their domains. Their domains are all real numbers, and the reason is because you're not dividing by any value of x, basically. Exponential functions, same thing. Their domains are all real numbers. You can raise a real number to any power, and you still have another real number. You're going to want to review the laws of exponents as we get into exponential functions. These are just laws of exponents from middle school and high school algebra, so make sure that you refamiliarize yourself with those. So the functions that we're going to be looking at that you're going to need to solve for their domains algebraically that are a bit harder because they do have limitations on their domains are rational functions and root functions. So the next few pages of our interactive lesson talk about rational functions, and then the pages after that talk about root functions where you have a square root in your function, or cube root, or nth root. In this case I have a square root. In this case I have a fifth root. So remember that if you have an even indexed root function, you're going to have to worry about your domain because you can't take an even index root of a negative number. When you have an odd index root function, like a 5 here, I can take an odd index of any number, whether it's positive or negative.